All right, so solving a 3 by 3 system using matrices. We've already looked at the determinant, and there was this determinant formula, but probably easier to remember finding the determinant where you wrote 2 more columns and then did the lines one way and lines the other way. So if I was finding the determinant of this one, I would rewrite the first 2 columns, diagonals this way. This will be 10 plus 6 minus 8. Diagonals this way. Problem with doing the diagonals too soon, sometimes you might not see the numbers anymore. 60 plus 1 minus 8. And so in the end, the first one adds up to 8, and then you subtract, and the second one adds up to 53. So we get a determinant of negative 45. No? Did something go wrong? Well, I might have. You did it a different way, and it didn't work, or? So something I would say that would be interesting just to glance at is the process of finding the inverse of a 3 by 3 matrix algebraically. A little Google search will show you. It is not a short endeavor. So we are going to use our calculator. And again, if the determinant is 0, no inverse will exist. So we want this one to have, if we want it to not exist, that means the determinant of P would have to equal 0. If you wanted to calculate the determinant, you could, again, rewrite those first 2 columns. 0 plus 4x minus 2. And the other direction, 0 plus x plus a negative 16. So our determinant will be 4x minus 2 subtract x minus 16. And if that determinant is equal to 0, now we just have to solve this. So 4x minus x will give us 3x. Negative 2 minus a negative 16 plus 14 equals 0. 3x equals negative 14. And so x is equal to negative 14 over 3. If you had a calculator, you could now enter this matrix into your calculator with negative 14 over 3 where the x is. Use the calculator to determine the determinant and make sure that it's equal to 0. We could. So I'd like you to type both A and B into your calculator, into the matrix program, and then calculate the inverse. So again, once you get in your calculator, if your calculator has decimals, you can hit the math button, and number 1 changes it to a fraction, and push enter, and it'll automatically change those numbers to a fraction. Oh, yeah. Now, you have an equation, matrix A times matrix P is equal to matrix B. If I want to get P by itself, matrices you cannot divide. There's no dividing in matrices. So in a normal equation, you'd say, oh, I'd like to divide both sides by A, and then I'll get the answer. But since there's no dividing in matrices, what we do is we multiply A by its inverse. Because anytime you multiply by its inverse, you get the identity matrix, and the identity matrix times anything is itself. So that will get rid of the A on this side. Now, if you put A inverse in the front of the left side, you have to make sure you put A inverse in the front of the other side. I was thinking about that. I don't know how you would put it in the middle. So since we already have A in our calculator, you can write A inverse. And since you already have B in your calculator, you can write B. You can push enter. And once somebody has done that, let me see your calculator and I'll write the answers in. Yeah, well, here, I'll let you steal them from me then. If I stole them from you and you steal them, is it still considered stealing from me? Legally, I believe the answer is yes. Yeah. So for example, I think there was one time when I was growing up that my dad sold a piece of farm machinery to another farmer. The other farmer decided not to pay him. Okay? So my dad was thinking he would go to the farmer and take his piece of machinery back, but he was informed that if he did that, he would be stealing it. Which is kind of, but it's, because it technically was sold, so now the other person owns it even though they haven't paid for it. Well, yeah. Maybe. Yes. Oh, you got a different number? So what should it be? Oh, is it completely different everywhere? Okay. 1, 2, and 0. That is much nicer. Is this what other people got? Look at that. That's a pretty answer. Yes? Okay. You put A inverse and B and push enter, and then you will get this answer. No. So using the inverse matrix in this situation, what we have is we would have first our coefficients matrix. So I would have 1, 2, 3, 1, negative 1, 1, 2, 1, 1. Our variables matrix and our answer matrix. And above this, I'm going to say, I'm going to let A equal that one and B equal the other one, because then what I really have is matrix A times matrix X equals matrix B. And using our calculator, if we put this into matrix A and that into matrix B, And again, this A inverse has to be in front. That's right. An identity matrix times any matrix that's possible. So here, A times A inverse will give us a 3 by 3 identity matrix. And that 3 by 3 identity matrix times the 3 by 1 is possible. And it will just be X, Y, Z. So in the end, this side will just become X. And here, we will get a 3 by 1. Does anybody have that answer? What do you get? 4, 1, negative 1. Okay? So we do the second one the same way. The second one, what are we going to do in the first equation if there's no z's? We're going to put a 0. One of the things you have to be careful with, and I'm checking it as I go along, is to make sure that things are in the right order. That we have x's first, then y's, then z's. Because if your order is off and you put things in differently, it's going to cause some problems. And did anyone by chance get that second one already? And what did you get? 5, 4, negative 1. So Michael had asked, can you multiply in the middle? I don't think so, because I was thinking about this question, right? We know A and we know B. So could we solve for this? And I don't think so. Or at least I haven't figured out a way that with that A in the middle, it causes problems. Yeah, I don't know. I don't think you could solve that. But it feels like you should, because there's only one thing you don't know, which is P, but it's in two different spots. I feel like there should be too, but I can't think of one off the top of my head. I mean, this is the same, this is the same question I kind of wanted to spell Papa B, right? Papa B would be the same difficulty of solving, because you could get rid of the A at the end. If you wanted to get rid of the A at the end, you'd multiply by A inverse on the end. That's okay. But you still have that A in the middle. I know, I was thinking, could I add an inverse of P to get the A by itself? But then if I added an inverse of P to get rid of the A, now I have a P inverse in the middle. Yeah. Okay. So you could go P and then A and then B inverse and A out in front equals P inverse. And then you could substitute all of this in. Oh, but then check this out. Yeah. So the A by the A inverse go away. Yeah. The A and the inverse of A goes away. The B and the B inverse, and we can prove that the inverse of P is, in fact, equal to the inverse of P. And this is a classic example of what did I do? I had one equation here. I started with one equation. I solved for a variable and used that variable to substitute back into the same equation that I had. That does not help you at all, but it will always prove something that is very true. Like if you want a really strong proof that 2 is equal to 2, that is a good strategy to use.
Have you seen the proof for 1 + 1 = 2?
Yeah, I've seen a couple of them. Okay. And oops, that's not the end button.